Envision looking not too far off and seeing a dawn that involves half the sky. NASA has delivered pictures of a never-before-seen phenomenon where a star named Betelgeuse went crazy, launching a huge piece of its surface mass. The event is known as a surface mass ejection, and according to the Space Organization, the discharge was 400 times the mass of a typical solar flare. From our Sun researchers described the event as watching stellar evolution in real time, with a star launching such immense chunks of its physical structure. Shockingly, the tremendous blast of this very red giant is challenging much of what we know about the universe. Why did Betelgeuse go crazy? And how might that affect the universe? Let's find out. Constellations are comprised of many stars and are arranged according to mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The bright ruby-red shining star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. When seen carefully, astronomers recognize it as a fuming beast with a 420-day-long pulse of regular throbs. Because of its bleak orange-red color, Betelgeuse is easily identified. It's ideal for convincing skeptics that stars do indeed have different colors. It is also known as Alpha Orionis and is the second brightest star in the constellation after the blue supergiant Rigel. Betelgeuse is an interesting object for star studies and observations due to its variable nature as well as its odd name. Frequently, stars with the name Alpha are the brightest stars in their constellations, although Rigel, Orion's other bright star, is brighter. Betelgeuse is Alpha Orionis due to its fame, brightness, size, and reddish hue. It is also one of the most well-known stars. The fact that this star served as the model for both the character and the movie Betelgeuse makes it significant. It is the seventh brightest star visible from most of North America, Europe, and Canada, and it is the 10th brightest star overall in the sky. Earth is relatively close to Betelgeuse. Astronomers can't pinpoint Betelgeuse's exact distance from Earth, although they believe it to be somewhere between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star and is closest to Earth in our galaxy. There are only 200 red supergiant stars that have been identified. The Sun has a radius that is about 764 times smaller than Betelgeuse. If the star replaced our Sun in the solar system, it would reach beyond the asteroid belt and even past Jupiter. This suggests that Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 15 to 20 times as massive as the Sun. This supergiant has 126,000 solar luminosities and is visible from 548 light-years away. This star has a surface temperature of around 3,600 Kelvin, making it cooler than the Sun. Only about 13.3% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all frequencies, Betelgeuse would surpass Sirius as the brightest star in the night sky. Betelgeuse loses around one solar mass every 10,000 years. The red star is surrounded by a cloud because this material is being ejected unevenly from the star in all directions. A cloud of material 300 times larger than the star surrounds Betelgeuse. The size of this cloud is also thought to be 30 astronomical units, or 30 times the solar distance between the Sun and Neptune, the farthest planet in the solar system. Our solar system's Sun regularly ejects mass into space, which is known as solar flares. However, the Sun only exhales small pieces of its outer atmosphere, known as the corona, giving the phenomenon the name coronal mass ejection (CME). As a result, coronal mass ejections and surface mass ejections can occur at separate times. When a star ejects a piece of its unstable outer atmosphere, it causes a CME known as the coronal CME. Coronal mass ejections from our solar system happen frequently and can affect Earth and its inhabitants. CMEs can travel more than 1,800 meters per second while ejecting magnetic fields and plasma into space, allowing them to sometimes reach Earth in a matter of hours. A CME can disrupt and harm Earth's satellites and power systems when it occurs on the side of the Sun that faces the planet. It occasionally puts astronauts in orbit in danger. The new discovery shed light on the rare cause of Betelgeuse's outburst in 2019. The material that the star shot out exploded into space, cooled, and created a cloud of cosmic dust that dimmed Betelgeuse's brightness from Earth-based observers. Additionally, Betelgeuse's famous steady throbbing pattern has been disrupted. The CME on Betelgeuse is rare because it ejected 400 billion times more mass than a typical CME, which caused the star to shake like a bowl of gelatin, according to a NASA news release. Andrea Dupree, an astronomer at the Center for Astrophysics, stated that the star's internal convection cells might be in disarray while the photosphere, the star's surface, struggles to rebuild itself. Astronomers have been following the star's steady pattern for the past 200 years, but it no longer exists. All red supergiants, including Betelgeuse, are dying, and being able to witness this process will allow scientists to learn a lot about the evolution of stars. Most stars in the universe are powered by nuclear fusion, which eventually runs out and causes a star to undergo a series of unique stellar changes before it finally dies. When a star is born, it is made of hydrogen, which under the power of gravity combines in the star center to make helium in an atomic blast. A ton of intensity and light energy is normally delivered during the combination process. This energy goes to the star's surface and is released as a photon into space. As the star ages, its essential fuel, hydrogen, runs out, and helium begins to join with carbon to form carbon. After the helium is spent, neon will ultimately join with carbon to form particles. When this happens, the combination of neon with particles ingests energy instead of releasing it. Since there isn't anything to oppose the star's exceptionally strong gravity, when particles begin to intertwine, the star collapses in on itself, leading to a cosmic explosion. A cosmic explosion, one of nature's most impressive forces, can produce more energy than 10 billion suns. Stars shift in tint during the course of their existence, from the youngest, hottest blue forms to the older, cooler red varieties, depending on what stage of their heavenly development they have reached. The Greek scientist Ptolemy, in 168 AD, oddly referred to Betelgeuse's color as having a reddish shade. 3 centuries earlier, Chinese astronomers had described the star as having a yellow appearance, perhaps inferring that Betelgeuse was previously a yellow supergiant. Astronomers might gain a better understanding of how red stars lose mass in their final days before detonating in a brilliant cosmic explosion from Betelgeuse's blast. As Dupree notes, we've never seen an enormous mass discharge on the surface of a star before. We are left with something going on that we don't completely understand. It's an absolutely new phenomenon that we can observe directly and resolve surface details with Hubble. We are watching heavenly evolution in real time, but it's unclear whether this evolution predicts Betelgeuse's impending cosmic explosion because the outcomes are so strange. NASA issued a caution, stating that Betelgeuse may not have reached the end of its life, even though it is approaching its end. Cosmic time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the focus of intense study since the 1st century BC. More recently, a scientist by the name of Sarah Nance and her team sought to determine the expected timing of the cosmic explosion of red supergiants like Betelgeuse. They ran various simulations using Betelgeuse as a model, then compared their findings with field observations. Why did Betelgeuse suddenly dim, in conflict with its regular cycle, when it is not likely to explode for another 100,000 years? Betelgeuse was expelled from its home in the Orion OB1 association, which includes the stars in Orion's belt. It has been seen traveling through the interstellar medium at a speed of more than 4 light-years wide. By mid-February 2020, Betelgeuse had lost 3 times as much brightness, from size 0.5 to magnitude 1.7, after starting to decline sharply in October 2019. By February 17, 2020, Betelgeuse's brightness had been stable for almost 10 days, and the star had started to brighten again. However, Betelgeuse appeared to have stopped dimming completely 5 days later, effectively ending the darkening episode. Given that there were no tremendous changes in the infrared on February 24, 2020, it appeared that the recent visual dimming was likely unrelated to a core collapse. Another study concluded that the star's dimming was most likely caused by a cloud of large-grain circumstellar dust. Absorption is ruled out from having a tremendous impact in a study that uses measurements at submillimeter frequencies. However, the dimming seems to be caused by large star spots. Further examination showed a dramatic rise in Betelgeuse's brilliance between May and August. Betelgeuse is so near the Sun that it is beyond difficult to see from Earth. Before 2020, when Betelgeuse was related to the Sun, it was about 0.4 in brightness. As per the perceptions made with the sound system, a satellite in June and July of 2020, the star had blurred by 0.5 since its past ground-based perception in April. Everyone was shocked by this, because the maximum and subsequent minimum were expected to happen in August, September 2020, and around April 2021, respectively. Betelgeuse's brightness was known to broadly shift, making predictions difficult. The blurring seemed to show that a second darkening event might occur much earlier than anticipated. The finding of a subsequent dust cloud coming from Betelgeuse, which was linked in June 2020, suggested that a cool patch on its photosphere might be the cause of the dust. In August, a second independent investigation confirmed the initial hypothesis. The dust is thought to have been made by gas that the star had shed. Studies done in 2022 using the Hubble Space Telescope suggested that a dust storm might have been created by a surface mass ejection. The material was ejected from the star's surface thousands of kilometers away, where it cooled, compacted, and formed the star's blurring dust. The disrupted photosphere, which was about a few times as heavy as our moon, traveled into space, cooled, and created a dust cloud that covered the star. From the perspective of Earth-based observers, the blurring, which began in late 2019 and lasted for a few months, was reportedly visible even to backyard observers who noticed the star's brightness change. Even more remarkable, the 400-day pulsation cycle of the supergiant has vanished. For around 200 years, astronomers have been tracking this cycle by analyzing changes in Betelgeuse's surface motions and brightness variations. Its disruption reveals the extent of the effect. Astronomers have now developed a likely hypothesis to explain the interruption. The star is also slowly but steadily regaining strength, and the photosphere is recovering. The star's usual cycle has been disturbed, and the interior is vibrating like a bell that has been struck hard. A massive stellar surface mass ejection like this had never been seen before, and there is still something going on that we do not fully understand. We may directly witness this brand new phenomenon and use Hubble to observe surface features. When will it happen? Probably not in our lifetimes, but nobody really knows. It could be, in fact, tomorrow or a million years from now. Will Earth be destroyed by the Betelgeuse supernova? No. The explosion of Betelgeuse won't affect or end life on Earth because it will happen too far away. Astronomers estimate that for a supernova to be dangerous to humans, we would need to be within 50 light-years of it. Betelgeuse is more than 10 times farther away. Instead, everyone on Earth will be treated to a spectacular view of a very bright star in the night sky. Finally, because of Betelgeuse's location, astronomers will be able to study the star when it undergoes a supernova. Betelgeuse, or Betelgeuse, is not currently visible in the night sky, so don't go searching for it. Even if it went supernova right now, we wouldn't see much of it, but it is in the late morning sky during August. Betelgeuse may have already gone supernova. Betelgeuse is not only an important star in the Orion constellation, but also plays a vital role in the study of stellar evolution. Its size and unique characteristics make it an exceptional laboratory for understanding the life cycles of massive stars. The star is classified as a red supergiant, a category that includes some of the largest and brightest stars in the universe. Observations suggest that Betelgeuse may eventually undergo a significant change, leading to a spectacular supernova event. This explosion is predicted to produce a neutron star, or possibly even a black hole, depending on the remaining mass after the explosion. Researchers are eager to gather more data about its behavior, particularly concerning mass loss rates and surface changes, which can offer insights into similar stars across the universe. In addition to its scientific significance, Betelgeuse has also captured the public imagination. Cultural references, such as the classic 1988 film named after the star, have cemented its place in popular culture. As it approaches the end of its life cycle, the interest surrounding Betelgeuse continues to grow, highlighting its significance both scientifically and artistically.